Okay, so today we'll continue from where we left. So we are doing the motion under gravity, right? And we derive some of the basic formula like time of flight, maximum height, time of ascent, time of descent. So we have been throwing the object from bottom. So what happens if you throw from some height? So let's say we have a tower. And tower is having height h. And from the top of the tower, we are throwing the object in the vertically upward direction with initial velocity u, because this is what you chose, right? So now earlier it was moving from here to here, it was going up and coming down to the same level. But now what will happen? It will come down till this level before it will make the impact with the ground, correct? Isn't it? So now the time taken to travel from the point of projection till the base will be more than before or same as before? Tell me, guys. The time of flight in this case should be more than before or same as before or less than before?
More.
More. Same. So earlier you were throwing from here, right? And it was coming back to the same level. And the journey was over. And now it is going to travel h distance extra, right? So the new journey is much bigger than before by h value. So while crossing the same height on the downward journey, at the same level, the ball will have velocity how much? What will be the speed of the ball at the same level?
U.
It will be u only. Is this clear to all of you?
Yes, sir.
But what we are looking for? We are looking for the time of flight for the entire journey. So the formula that we derived earlier will not be applicable here. We have to re-derive for this particular situation. And as I said, to solve any question in vertical direction, you have to use the kinematical equation in vertical direction. And you have to use the proper coordinate system. Now, the choice of coordinate system, the choice of origin is user dependent. You can choose whatever you want. But once you make the choice, you can write the things accordingly. So tell me, guys, where you would like to use the assume the origin. Do you want it to be at the point of projection or at the bottom?
At point of projection.
So let me draw it first. If this is your point of projection, if this is y direction, this is origin. So at the end of the journey, first of all, at t equals to 0, what is the y coordinate? What is the y coordinate of the ball?
0.
Y coordinate. How much? I am asking what is the y coordinate of the ball at t equals to 0? Siddhant, how much?
Sir, U.
U is the coordinate. Come on, U is velocity.
0.
0. Very good. Excellent. So I'm asking y coordinate, you're saying U. Why? And at the end of time of flight, what is the y coordinate? I hope you know the coordinate axis origin meaning. So what is the y coordinate? Tell me, guys.
Minus H.
Very good. So now you're getting it. So you know the y, not you know the y value. Do you know the v value here? Do we know the answer for v also? Yes or no?
Yes.
No, we don't know. Is it given in the question? Yeah, we can certainly derive it, but do we know as of now?
No.
No. So you have been given initial velocity u, you have been given the height of the tower as capital H. And you are supposed to find the time of flight. So which kinematical equation we should use to get the time of flight? Tell me. Second one, very good. So what is the second equation? What is the second kinematical equation, guys? Tell me.
S equals to UT plus half H square.
So in terms of coordinate, how to write? We should replace S by
Y minus 1.
y minus 1. Very good. So I'm getting an answer from only one guy. What are guys doing? So the displacement is final position minus initial position, because that is the definition of displacement in the y direction. So y minus y not equals to?
U by T.
Very good. Plus?
Half A.
Half AYT square.
So can you substitute and tell me the answer? So when small t we replace by capital T, then the corresponding values we can substitute. By the way, what is AY here?
Minus G.
Very good. Any doubt in this, guys?
No, sir.
So what is the answer? Tell me. Solve it and tell me the answer, everyone. Are you guys solving this?
Yes, sir.
Rugved, Prashansha, tell me, guys. Have you really understood this part?
Yes.
Solve it. So Rugved, in paper 1, I can see question number 3, 4, 5, 6, 7. And 10. 8 and 10. As well as, okay, this much is good enough. So these were discussed in the class itself, isn't it?
Yes.
So did you solve this question?
I did the fifth one, seventh one, fourth.
And fourth,
Bus. Only that much I did.
and the rest you fluked.
Yes.
So stop fluking, okay. If you know something, answer it and make a habit of this. If you don't know something, never ever answer. Clear?
Yes.
So next time I don't want, you're just, fluking in every question. Either solve it, get the answer, or leave it. Okay, got the answer, everyone?
Yes, sir.
Very good. So there is no theta here. How you got theta? Shreya, tell me. Where is the theta? And how you got theta at all in this entire answer? So you mucked up some answer, some formula which you're trying to say it here. You haven't solved at all. Solve it for better understanding. Okay, so y is minus s, y naught is 0, uy is u, t is capital T, plus is plus, 1 by 2 is 1 by 2, ay is g, t is t square. And this is the quadratic equation, right?
Yes, sir.
So if I multiply two both sides, and I hope and believe that you guys know the how to solve quadratic. So what we are trying to figure out here, t value. And because it is quadratic in t, how to get the answer? Tell me.
We can use the quadratic formula.
Yeah. So what is the formula?
Minus b plus minus root of b square minus 4ac.
So minus b means 2u because it is already minus 2u. So minus b plus minus under root of b square. How much?
4u square.
Minus 4ac. How much?
Plus 8gh.
Excellent. Upon
2g.
2g.
2g. Now again, because we are solving physics, we are not solving mathematics, so we have to eliminate those options which is giving non-realistic answer. So can we have negative time? No. Time cannot be negative. So which option will be correct? The plus or minus?
Plus 1.
Plus 1. And also you can see we can take 4 common from the root term. So it will come 2u plus twice we can take outside. U square plus 2gh. Sorry. Upon g. Now this 2 gets cancelled. So the answer is u plus . Is this clear?
Yes, sir.
Okay. All right. So this is your answer. And basically this is simply v equals to u plus at formula. Okay. So t is equals to u plus under root of u square plus 2gh upon g is the answer. All right. Now, can we calculate v value? Okay, at the maximum height, what will be the v value?
0.
0.
But I'm asking this value, not the maximum height. V just before impact. And always remember, in kinematics, never ever try to remember even a single formula. Rather learn how to derive on the go. In fact, every question can be solved in hardly 30 seconds, even if you use just formula. I mean, sorry, just derivation. So derivation can be done in less than 1 minute. So make sure that you learn derivation. Is this clear? Is this clear, guys?
Yes, sir.
Yes, sir.
Okay. No. The same question can be asked in a very nice or a different manner. So imagine, okay, Diwali has passed now, but you all have used the Diwali rocket, right? Everyone has used.
Yes, sir.
So in the Diwali rocket, you must have some fuse layers. or you can say fuse, and there is a gunpowder inside. So the moment you burn the fuse, what happens? Eventually, it catches the gunpowder catches the fire, and the moment gunpowder catches the fire, it converts into gas. So powder is a, you can say powder means solid actually, and ignition or burning converts into gas, and the expansion that you should know actually, the gas will expand roughly 400 times. So in that tiny cylindrical pipe, the gunpowder, imagine if expanding 400 times, that gas will try to escape, and while escaping, it will create a thrust force, and that will lift the rocket upward. So it means the thrust force that the gunpowder generates is much more than gravity force, and eventually it accelerates upward. But after traveling some height, the gunpowder will get consumed completely. And the moment all the gunpowder is getting consumed, what will happen to the rocket? Will it come down or will it go up and come down?
Go up and come down.
Is this clear to everyone?
Yes.
Because by the time the fuel gets consumed or exhausted, the rocket will have some velocity, isn't it? And because the rocket will have some velocity, so with that velocity, it will make some upward journey further till that becomes zero. And then it will come down. So if I take the gunpowder duration as the accelerating duration, and then once the gunpowder is getting consumed, so while it is going upward with gunpowder creating the thrust, can we call motion under gravity?
No, sir.
No. Very good. How many of you are not able to realize this? That the rocket going up is not the motion under gravity till the gunpowder is burned. Anyone who is not understanding this part? So you all agree that it is not motion under gravity?
Yes.
Yeah, Prasansa, tell me. Are you getting it?
Yes, sir.
Rugved?
Yes, sir.
So when the motion under gravity will begin?
So just after the gunpowder is consumed.
Yeah, it means the moment the thrust is off, the motion is only under gravity. As long as the thrust is present, we have actually thrust and gravity working together. So it is motion under two forces, thrust force and gravity force. It is not called motion under gravity. So the laws of motion or the kinematical equation, you are not supposed to apply for motion under gravity. So what you can do? So what I'll do is imagine, let me draw this rocket first. Okay, so this is your rocket. A nice rocket. Huh? Which brand? In Mumbai, we use standard, very common. So this is the fuse. So what we are going to assume is, okay, let me write down this. Assume the rocket starts from rest. When I say starts, it means it is by default from rest. Accelerates upward for time t naught with uniform acceleration a naught and then okay. So that is sufficient. So it is only accelerating for time t naught with an acceleration a naught, and you have to ignore the dimension of rocket. So this is just a symbolic. So it is like you're throwing, let's say there is some device which can fly. You can represent rocket by a ball or some dot which accelerates with the acceleration a naught for duration t naught, and then it will move under the gravity. So the question is fine. So what we are supposed to find? Maximum height from the point of launch total time of journey since launch. So the total time of journey will be, it will accelerate for some time, will move further up, will come down, and eventually hit back the ground. So you have to find the total time of journey. You can also add t naught to the journey. So that's totally okay. Yeah, that's it. So attempt this question. Question is clear what we are supposed to do? Tell
Yes,
me
sir.
guys, is the question clear to all of you?
Yes, sir.
Okay, great. So go ahead and solve this. Any progress, guys?
Yes, I found maximum height.
Okay, great. Done? To understand this better, what is happening? Let's plot the graph called VT graph. So now tell me, guys, for how long the ball, or you can say rocket, will accelerate? For how long?
30 knots.
Yeah. So how the graph will look like? If the acceleration is uniform, it will accelerate like this. Correct? And the time we can draw as T naught. And this angle will be how much? Tan of this angle will be. So this acceleration is A naught. Correct? So for T naught, it will accelerate with constant acceleration. What will happen after that? What will happen? Tell me, guys. The moment T naught is over, what will happen next?
The motion in the gravity.
So it will have some velocity V naught here.
Yes, sir.
And with this V naught, we can calculate V naught in terms of A naught and T naught. And then it will perform the motion to gravity. So it will have basically a retardation. Why? Because you are trying to go up and gravity is putting you down. Okay. So the next graph will be like this. But area under the VT graph gives you displacement. So when velocity will be 0, this is your maximum height point, correct? What is T1? Maximum height, yes or no? Do you realize this, that T1 is the maximum height? Okay, you're not able to realize. What is the meaning of area under the VT graph? What is the meaning of area under the VT graph? Tell me, guys.
Displacement.
Displacement. So up to this point, displacement is positive because the area is positive, yes or no? The entire area is above the t-axis, so this area is positive, yes or no?
Yes.
It means till the point T1, the object is going upward only, yes or no?
Yes.
But eventually you have to come back to the same level, which means the displacement must decrease again. So graph will continue in the negative direction like this. And at time of flight, which means when you come back to the ground, this interval is your time of flight. Do you realize this? And this slope is famous. Okay, let's call alpha, this called beta. So this, the beta is representing value of G, right? So tan alpha is A naught, and what is tan beta? Tan beta is G, because this is the value of retardation. Anyone able to realize this? No. I think hardly anyone is getting this graph. Huh? Are you guys getting the graph?
Yes, sir.
Okay. So can you find the T1 first of all? What is T1? What is T1 here? Okay, first of all, what is V naught here? Using graph, you can find V naught, right? Slope of VT graph gives the acceleration. So can we write A naught equals to tan alpha equals to V naught by T naught? Why you guys are quiet? If you're not getting, raise your hand. So I'm trying to solve by simple method. If you want to, I can do it by the equation method, that is lengthier. This is much easier. So tell me, guys, can we write A naught equals to V naught by T naught?
Yes.
So V naught, we got A naught T naught. That's anyway equation of motion. That is done. How to get T1? So T1 you can get easily using this tan beta. So tan beta is how much? G, and this is how much? V naught by, tell me how much? No idea.
T1 minus T0.
Excellent. Correct. So T1 minus T naught is V naught by G, which is A naught T naught by G. So this implies T1 turns out to be T naught plus A naught T naught by G, which is T naught into 1 plus A naught by G. So you got T1. So to get maximum height, what we are supposed to do? Tell me. How to get the maximum height using graph? Maximum height means till you keep on moving upward. That's the meaning of maximum height. So at the maximum height, the velocity becomes.
Zero.
0.
So velocity is zero at which point? At what instant velocity is zero? Can you see the graph and tell me the answer?
T1.
So
T1.
up to T1, the area and the graph must be giving you maximum height. Yes or no? Tell me, guys. Yes or no?
Yes, sir.
So can you find this area? Because that's very easy. Area under the graph is how much? Up to T1. Okay. I thought you guys understood the VT graph, but seems like VT graph is not very much clear. Huh? So we can say for maximum height, H max equals to area under VT graph from 0 to T1. So area is half into base into height. And this we got T naught. And V naught we got. Check Siddhant. Is this your answer?
Yes, sir.
And you can see that this is pretty easy. How you solve? Using graph or using
Sir,
equation?
equation.
Equation. Very good. So now you understood using graph also.
Yes, sir.
So do you realize the power of graph? Anyone able to realize the power of graph? How powerful the graph is? How we can solve even a complex question using graph easily?
Yes.
Okay. Now, how to find time of flight? So time of flight means you have to find the t actually. Okay. Just a minute. Okay. The next part. What is happening at capital T? You are returning back to ground, yes or no? And what is the meaning of returning back to the same point? What is the displacement?
0.
So how to get zero displacement? We have done this. If this is positive area, this is negative area. So for zero displacement, what is the condition? These two areas must be
Equal.
equal. And we have done again question like this also in VT graph. Can you tell me how to find this area and that area? So find both area because you, by the way, you know this area. We have just calculated, which is the area of the graph, which is H max. Can you find this area, the bottom one, the negative one, in value only, and equate it to get the T? So if you want to try, you can try for next 4 or 5 minutes. Then I'll solve. So how many of you are clueless about what is happening here? Rugved, Prashansa, Shreya. Are you guys getting this?
Yes.
So do you realize that the time of flight is basically the area is 0, the net area?
Yes.
And can you find the area in the negative part, the below area, using geometry, trigonometry, and so on? Okay, anyway, I will do, but you can try. Always remember, any question which is based on constant acceleration can be solved with VT graph with ease. And this is what we apply when we solve question like this. Anyone getting the answer? To find this area, you need to find this height first. Let's call it anything. So how to get the H naught in terms of time t? Because we cannot afford too many variables. So you can write tan beta equals to H naught by T minus T1, right?
Yes,
So
sir.
H naught is G times. Don't substitute now. So this area will be how much? So the first area was half into base into height minus half into base into height. So V naught T1 is T minus T1 into H naught. And H naught itself is G into, I think this one, right? So V naught T1 by G and T1 we got. V naught also got. So we can write as and T1 is like this. So T equals to T1 plus under root of and again I need to substitute T1. T1 was T1. Just one. Okay, so this is the T, a really bad answer, but this is the answer. So anyone getting this answer? Yeah, so this is the answer.
So it should be G plus A naught no, inside the bracket.
Yeah, yeah, this is A naught.
Yes, the same answer.
Very good. So you can take this as common. So this is the nice looking answer eventually, right? Anyone who is who has really understood this part. If not, then let me know. I'll explain once again. Prashansa, Shreya, Rugved,
Yes, understood.
Harry, you understood?
Understood. Yes, sir, understood.
Okay. So this is slightly difficult one. So now you can solve one easier one. That is the question number 24 of SC Verma. If you have book, then it's good. If you don't have, let me know. I'll send you the photo. Everyone is having the SC Verma?
Yes, sir.
Okay. Anyway, I'm sending it. So you can solve again this question using the graph or kinematically question. Both are possible. I'll prefer that you should do with graph so that you can understand the graphical approach. So question number 24. A very similar question, but slightly different.
Sir, is there any other method to solve this question?
Yeah, you can use basic analytical equation. So you can draw a graph like this. Diagram like this. So for the time t naught, it will accelerate. So how much it will travel upward? If your acceleration is a naught, and if you start from rest, what will be your displacement in time t naught? Tell me. If you start from rest, so your initial velocity is 0. You accelerate upward with an acceleration a naught or time t naught. What will be your displacement in the upward direction? Which kinematical equation?
V equals to U plus A.
Yeah, that gives you displacement.
No, S equals to UT plus A.
Yeah, so how much is the answer? You start from rest, you accelerate for time t naught with an acceleration a naught. How much will you displace upward?
Half A naught T naught square.
Excellent. So this will act as height, h. And by that time, how much velocity will gain?
A naught T naught.
So that will act as u. And then it's simple, no? It will come like this. So we know how to solve this question. We have just done this question, right? So what is the time of flight? U plus under root of u square plus 2gh upon g. I think this was the answer. Correct? So A naught T naught. A naught square T naught square 2G half A naught T naught square upon G. This is the answer in one line. Okay. So T naught will come out what we left with A naught square G. Oh, sorry. So we are left with A naught square plus A naught G. Yeah. Something is missing in our equation. This is something wrong. You need to check this. So you can take A naught square common. A naught T naught. That's the better way of writing. This is A by G naught.
Yes, sir.
Yeah, something is wrong. You need to check actually. This is the right answer for T. And what we are getting is something different. So somewhere we have missed writing, but let me just check. Half into base into height. So T1 we were getting this much, no? T1 is okay. T1 is T1 minus T naught. Okay, this is fine. G equals to V naught by T1 minus T naught. That's correct. That's correct. Yeah, now T naught by G. Yeah, T1 is correct. I think T1 is correct. And H max is half into base into height. So that should be. We can also check the H max from here also. So H max we can get from the this part we know the answer. You can get this answer. This is V0. So this H max will be how much? So we can use the third kinematical equation from there to there. V square equals to U square plus 2AY. Y minus Y naught. 0. So we know the formula of H max anyway. But always make a habit of derivation. So this will become A naught square T naught square upon 2G. And therefore the maximum height from the ground will be how much? From bottom it is half A naught T square plus this value, right? So let me write down. H max from ground equals to half A naught T naught square plus the answer which we got. So what we can take common? And how much we are getting here? Same answer. So let me check what we missed. Half into base into height. Okay. So half into base into height. Half into base into height. So Okay, I made a mistake somewhere here in writing actually. This is correct. So T1 V naught equals to, and H naught was how much? So T minus T1. Yeah, so we'll take this plus value only, not the minus value. So T turns out to be T1 and T1 was T naught plus V naught on T1. G1 A naught. This way it is becoming different answer. This is different. This answer is how much? Is the answer matching? I think so. T naught 1 plus A naught by G plus T naught by G. And that is correct only. Why different answer? This is interesting. Area under the curve is 0, so this is okay. Half into base into height. Equals to- Okay, okay. I think both answers are correct only. So what is the mistake is the T is taken from beginning, right? And here that this T is from the point of projection. That's why these are different answers. Okay, both are correct answers. This is correct. This is also correct, but this T is actually from where? So we are taking T0 here, then this is T, right? And if you add T naught, you get both answers, same answer. I hope this is clear now. The difference was due to the this T is measured from where? Since beginning. Measured since beginning. And this T is from where? This T is from where to where? It is not from beginning, it is when the fuel is consumed. Is this clear, guys?
Yes.
That's why the answer was mismatching. Okay, I thought, okay, why it is different answer. Okay, so both are correct answer. It is just a matter of interpretation. You'll get the same answer anyway. I hope this is clear. You can subtract T naught here, you will get the same answer. What we are getting here. Okay, so no need to do the calculation. Question number 7 solve.
Sir, it was 24, no? It's your mark.
Yeah, 24. Sorry, I'm saying 7. 24 is your mark. Done, guys.
Yes, sir.
So you can check the answer also. Do you have the book? You can check the answer. Is it matching?
Yes, sir. It's matching.
Very good. Siddhant, you got the answer?
Yes, sir. I got 4.28 seconds.
Okay, great. I think answer given is that only. Is that the answer given? Okay, you have to also be careful with the value of G taken because in SC Verma, unless SC Verma has not mentioned that it is 10, you are supposed to take 9.8. In the question itself, if they mention take G10, then only take G10. Okay. So that should be
Yes, sir.
borne in mind while solving numerical in SC Verma. Okay, anyway. So let's go to the next part of the same problem. So we were actually throwing the object from height h and we got the time of light. So now the question is, with what velocity it will impact or will make an impact with the ground, or it will hit the ground. So find speed. I'm asking speed only. With which it will hit the ground. So which kinematical equation we should use? Because you want a U and V relation. Given is H. So tell me which equation is the best way to get the answer. Anyone?
So third equation.
Very good. Excellent. So go ahead. Try to substitute value accordingly. And tell me what you're getting. How much V is coming? Questions are tell me. How much V is coming? Tell me guys quickly. So the third kinematical equation is best way to go, but you can also use other method also. But third is best. So Vy square equals to. So let's take this as origin. What is Vy? What is Uy? What is Ay? What is Y? What is Y naught? If you can read and write the values with proper sign, nothing can go wrong. Now, those who are having doubt in this equation, let me know.
So why would we take minus V?
Because the direction of velocity in the downward direction. And Vy means what is velocity in the y direction. So is V in the y direction or opposite of y?
Opposite.
We put minus. Clear now?
Yes, sir.
And that's why I have put a u equals to u. Because it is upward. So we are taking y-axis like this. So everything facing upward will have positive value. So those motion which is happening upward is positive, and those motion happening downward is negative. And origin is there, so we can write the coordinate of y and y naught. So what are we getting here? So this is the speed actually. or you can say magnitude of velocity. Okay. Now to get the time of flight, there is a even simple way, because now you know V, you can use the first kinematical equation. What is that equation? So we can add Vy equals to minus V, U equals to plus U, Ay equals to minus G, T equals to capital T. That's it. So simple. So what is the answer? Gt equals to U plus V. So T is value as U plus V by G. And that's why the answer is. Is this clear, guys? Yes or no?
Yes, sir.
Yes, sir.
So do you realize that it is really good to find the V first and then use the kinematical equation, the first equation to get the time of flight? Because anytime you know U and V, you can get the T, correct? Okay. The next point. So now we have a tower. So now this is a tower and you drop something. Okay. So now as this ball will descend, its speed will keep on growing, right? Yes or no?
Yes, sir.
Now imagine, let's assume that it takes just 2 seconds, not two is too much, too small. So let's take it takes 5 seconds to reach the bottom. It takes 5 seconds to reach the bottom. So if I divide each interval into 1 second, then in which second it will travel maximum? The first 1 second, the second 1 second, the third, or the last? So the
Last.
total journey is 4 seconds. And if I divide into each interval into 1 second each, then in which interval it will travel maximum? The first or the last?
Sir, the last.
Last.
Last, because it is speeding up. So definitely it will travel more and more as it will come down. So if it is given to you, what is going to you? That in the last second, if h is distance traveled by the ball in its last second of journey, nothing is given. Only what is given is that it travels H in the last second of its its last second of journey, then find the height of tower. This is given to you. You begin with a rest, begin from rest, and then capital H is supposed to be found out. So solve this question. It's pretty easy.
So can you show the solution to the 24th question?
24th question.
Yeah, the HC one.
So what is given in the question? Can you read the question?
Ball is dropped from a balloon going up at a speed 7 meters per second. If
Correct.
the balloon was at height 60 meters at the time of dropping the ball, how
Yeah. So
long
when
will
you
the ball?
drop the, yeah, when see everything which is moving with the balloon or the parachute, if you are inside it, what will be your velocity? Same as balloon?
Yeah,
Yes or no? So the velocity of the stone inside will be also same as balloon?
yes,
Yes or no? So at 7 meter per second, when you release something, will it go up or down?
down.
No, that's a mistake. When you release something, it means it was already moving up with 7 meter per second. So with that speed you release, no? So you are going up with 7 meter per second. So everything in that balloon or parachute is moving with 7 meter per second. Do you realize this?
Yes,
So the moment you release, it will go up first, no? Because 7 is upward velocity. It is not 0. So you will go down only when it is 0, no? Not able to realize, huh?
yes, I understand.
Understood? See, you're releasing not from rest, you're releasing with a speed of 7 meter per second in the upward direction from a height of 60 meter. Is the question clear?
Yes,
So you can use the formula which we derive to get the answer. Okay?
yes,
So you can solve this. So is this method clear, guys? How to get time of flight once we know the V? So once you know the initial velocity and final velocity, you can always find the time of flight. Understood? You know what is fascinating? There's something very fascinating. This formula which we got here. This is also true even in the presence of air resistance. Even if I bring some air resistance into picture, then the answer of time of flight remains same. It is u plus v by 2. But now this is not true. This is wrong. Because in air resistance, this formula will not come. But if I give you u and v as the initial and final velocity of the journey, then the time of flight will be u plus v by g. In this case, whether air resistance is present or not, both answer will be same. But if there is no air resistance, then the V can be converted into this formula. That's the only difference. Hopefully, this is not what you understand today. You will understand after some months in a chapter of conservation of momentum. System of particle. Okay, so before you solve this question, can you simply solve this question? Because this will help you in solving previous question. So a ball is released from height capital H. So release from rest. What will be the time of flight? So who will bring it down?
Gravity.
So gravity in time t will pull you down by what value? Okay, you don't remember the last lecture.
U/G.
No, it's half gt square. So gravity always pulls with half gt square. Anyway, so you can assume some coordinate system, substitute the value, and tell me the answer. Please go ahead. What's the answer?
So root of 2h/g.
Correct. Very good. So it is under root of. You have to follow the same rule. No? Write the canonical question, get the answer. So which canonical question you applied?
So the second one. S is equal to UT plus OT.
Very good. So what is S here? S here is
Sir, H.
H, or you can say minus H or H depending on the coordinate system. So H equals to half gt square, T will be under root 2h/g. Okay, so you can use this to get the previous answer, hopefully. I think I have given the formula displacement in the nth second of journey. Have I given the formula? And even if you don't remember, you can derive from basic. common sense. You just tell me the equation, what you are writing. Done, guys? Siddhant, Rugved, Harry, Prashant, tell me. Use some common sense. Now, common sense means like you know that it will travel, let's say it will travel the entire journey in time capital T, right? So to travel h, you need how much time? So to travel h minus h, how much time you need? Tell me. Anyone? To travel h minus h, how much time you need? Am I audible?
H minus H into T by H.
No. You travel in time t the full height. And because small h is the distance you travel in the last second. So to travel the remaining height h minus h, how much time you need? Once again, you take time t to travel h height, correct? In the last second of journey, how much you travel? In the last second of journey, how much you travel?
Small h.
So to travel the remaining part, which is h minus h, how much time you need?
Root 2 h minus h by.
You just need to 1 second less, isn't it?
Yes. Sir.
See, h you travel in the last second, no? So out of t time, you spend 1 second to travel the last h. So the remaining h minus h you will travel in how much time? T minus 1 second. So you can add h minus h equals to half g. That's it. So what is your answer? H minus h equals to, and t itself is how much? So no need to solve this question. You can just keep it as it is. Or if you want to solve, you can rearrange and square it. You can get the answer. So now this is the only variable here is capital H. Small h is known to you. G is known to you. And so you can get the answer. Is this clear? How to get the answer?
So how do we know it travels h distance in 1 second?
It is written.
In one.
Read the question. You haven't read, right? What is question saying? Tell me. What is question saying?
It travels smallest distance in the last second of it.
Of its journey. So if you have journey for 1 hour, so small h is the distance which you travel in the last second of that 1 hour. Understood? That's the idea. Clear?
Yes, sir.
So basically, you can simply write the full h is half gt square, and the h minus h is half g t minus 1 whole square. That's it. And using these two questions, you were supposed to solve. That's it. Is this clear? Any doubt in this, guys?
No, sir.
No, sir.
Very good. All right. So the next part is, so it's again very famous question. So on a tall building, imagine from the rooftop, this is your window of your hall or your flat. And given to you is the height of the window. Is h, and you release a stone from the rooftop. So this will come down. So it comes down here, let's say called t time. I mean, this is actually not given to you. So what is given to you is that this ball crosses the window in 1 second. So find capital H. What is given to you? Small h. Find a small capital H given height of window small h. So these are the information. Can you solve now? Hmm.
It's a day like any.
You are only supposed to fund the relationship. That's it.
Sir, I got my answer.
Yeah. Tell me the equation which you wrote.
Sir, I got h equals to 4 small h square plus g square minus 4gh by 8g.
Okay, I think we have substitute. Okay, can you start with the equation? How you solve?
Yeah, so sir, at the topmost point of the window, its velocity will be root 2 g capital H.
Correct, correct.
And at the lowest point, it will be root 2 g small h plus capital H.
Yeah, correct.
And then, sir, I substituted the value on the first equation, v equals to u plus 18.
Very good. And time is given as 1 second, right?
Yes, sir.
Yeah. So very good. So V2 equals to V1 plus GT. That is G only, right? T is 1. So I hope this is what you used, correct?
Yes, sir.
Very good. Excellent. So find the capital H, of course, you need to square it first. So you can take the root thing one side. You take root 2g common. And now you can square it. So I think you need to square once again, right? So you have to square once again and then look at the answer, correct? So you will get a very complex quadratic equation, but what I'm really looking for is this relation. That's it. So generally they will give you a nice value so that you can rearrange and solve. Symbolically, you can ignore this complex question. Okay. And because it is all inward, all downward journey. To solve question of all downward journey, you can choose bottom as downward as y-axis. That's easy for you. Then everything becomes positive. So that's why this question will follow this convention. Or you have to put minus everywhere, which will cancel out. So is this clear to everyone?
Yes, sir.
The next part. So again, this is a very famous question called the leaking tap. Okay. So what is leaking tap? So when you close the tap, you must have seen that a small droplet of water will keep on, falling down at a regular interval. Have you seen that? Maybe somewhere, at least in movies or in some ad. Okay. So you have a tap. And droplets are leaking at regular interval. So the first drop will travel forward, and the interval after which the second will come out, the first will be ahead, right? And when third will come out, we keep on increasing like this. So imagine the bottom is here. This is the ground. And if you follow this diagram on itself, this is your first drop. So question is, if T naught is the interval, find position of each drop with respect to ground. So you're supposed to find the height of each drop from the ground. At the moment the fourth drop is leaving the tap. I hope the question is clear to all of you.
Sir, is the height of tap given?
That is your question itself, because the fourth drop is the height of the tap, right? What is given to you is interval. So the time interval between every two gap is how much? T naught, T naught, T naught. So how far is the ground from the topmost point? How far is the ground in terms of time interval? Like, or you can say how much a drop will take to reach the bottom? A drop will take how much time to reach the bottom?
3T naught.
3T
Exactly.
naught.
So that is the given answer. I mean, the time of flight is given to you for every drop to reach the bottom. And because time is given to you, can you find the height? Can you find the height? Yes or no? So what is the height of the first drop from the ground? Height of first drop from the ground is how much? Tell me, guys. What is the height of the first drop from the ground?
So 0.
Exactly, 0. So similarly, can you find the height of the second, third, and fourth with respect to ground? Try this out. Take your time.
So I had a doubt in the previous question.
Done, guys? Come on, guys. Is it done now? So do I need to solve this? Siddhant?
Sir, I think I got it.
Very good. See, the simple thing is, you know that the total time that a drop will take to reach the bottom is 3 T naught. So for any drop, sorry, for any drop, if you release, if this is T is equal to 0, this T is how much? So if I call this as H, can we write H equals to half G 3 T naught whole square? And this is also the answer for the height of the fourth drop. So this is the height of the fourth drop, yes or no? This is the height of the fourth drop, yes or no?
Yes,
Yes.
sir.
Yeah. Now to get the height of the third drop, what we are supposed to do is, the third drop is basically how much? T naught below from the top. Okay. So H minus height of the third, that's called H3. Well, that's not required. If you call this as H3 and if you call this as H2, and if you call this as H4, okay, I think I have taken the wrong diagram. Just a minute. Just a minute. So I hope you can see H1, H3, H4, right? So H4 is how much? 9/2 GT naught square. How to get H3? So H3 from bottom we need, na? So from top it is how much? So this is how much? You can check. From here to here, this is. And how much it is away in terms of time from the top? It is only T naught away. So this is how much? Half G T naught square, because you are exactly T naught below in terms of time. And H4 is how much? H3 turns out to be how much? 4G T naught square. Am I right?
Yes.
Similarly, can you find the H2? So tell me the answer for the H2, guys. H2, you can see now how far is H2 from the top. So H4 minus H2 is basically 2 T naught away, right? So the answer is 0. Now this question actually comes in a more complex way with assuming there n drops coming that way. So you can solve question number, I think 26 from S.C. Verma.
So can we find H2 by using H3 minus H2?
Yeah, definitely. You can use anything.
So, but I'm getting 7 by 2 G T naught square.
No. The thing is, the time we measure from the top, right? So H3 is T naught below her, isn't it? H3 is traveling only for T naught time. So if you take what you are taking, H3 and
H3 minus H2.
then you can't use. Now, if you use H3 minus H2, then at this point the initial velocity is not 0. So half GT square we cannot use. We have to use UT plus half DT square. UT plus half DT square. So that will make it complex. But you're getting it, what I'm saying. Always write the equation from the point at which you start from rest. So that the first term of the displacement equation, UT, is 0. So this is the question number 26, basically. Question number 26. But they're asking from top only, so that's easy one. Is this clear, guys?
Yes, sir, I got my answer.
Very good. Siddhant, you got the answer?
Yes.
Prashansa, Rugved?
Yes, sir.
Rugved,
Yes, sir.
yes, sir, means not getting the answer.
No, I'm still doing.
Okay. And those who have solved the question, you can go back to question number 29 and solve. So we have solved similar question, but you can solve this question. Question number 29, everyone. So 29 is clear, like how to approach, because we have solved something similar, not exactly. Tell me guys, you got the answer for 29 and 26.
Done, sir.
Very good. So 29 is done.
Yes, sir, both.
Both. Then solve also 27, 28. Finish it off. Then I'll give you a tough assignment.
Sir, can you please go to the previous slide?
Yeah. This one.
Yes, thank you.
Are you guys solving 27, 28?
Yes, sir. I am on 28.
Okay, very good. Rugved, which question are you solving?
27.
Good. The rest you got 26 you got?
Yes.
Pakka?
Yes.
Very good.
So can you please solve the 26th one? I'm getting a wrong answer.
26th one. So you're dropping at regular interval. Okay. So the third ball will be 2 seconds away. Correct? So nth ball will be always n minus 1 second away from the top. So you can write the answer. The distance of the nth ball from the top, you can directly write as half g. And you can keep on substituting the value of n, you'll get the answer. First, second, third.
So won't the third ball be 3 seconds away?
Just a minute. No, not 3 seconds. No. See, you drop the first ball. This is 0 actually. So when the 1 is here, the 2 is here. Okay. So what is the gap of when you drop the second ball? The first ball is only 1 second away. Understood?
Yes, sir.
Yeah. So when you drop the sixth ball, the sixth is here. So fifth will be here. Fourth, third, second, first. You can think this way. So how far is the first? Count the second. 1, 2, 3, 4, 5. So you can say it's the other way of writing. I should have written other way around. So the first ball is 5 seconds away. So you can find the position of first ball as half g. Then okay. This is the first ball. The third ball will be 2 seconds away. And so on. You can check the answer.
So I've sent you my.
Okay, okay. Let me check. This is always 1 second difference. They're asking the height from the top, not from bottom. You're getting from bottom.
Yeah.
But if you read the question, this is a different question. No? Find the position of the particle actually from the top only. Bottom is not there. There is no mention of bottom, right? The bottom is not mentioned. No? So you have to answer the question from top itself. Okay. And if you read the question, if you read the answer, they have mentioned that answer below the top. Correct?
Yeah.
So you have to find the answer from the top only. Okay. I hope this is clear.
Yes, sir.
Okay. Now you can solve 27, 28. Siddhant, done? 28.
Sir, on the 28th.
Harry, you got the answer?
Yes, sir. Done.
Okay, very good. So we have to discuss the last problem of from this topic. Then we can move to the oblique projectile very soon. I mean projectile motion. So you can keep on solving. Let me solve the last two problems. So there is a shortcut when we study something called relative motion, but right now we would like to solve using the very basic method. So it's called the elevator problem. Okay, so the problem is, I should have done this movie. Just one moment. So this is the elevator. So there are multiple cases that we can discuss one by one. So you're throwing a ball in an open elevator. So you can see the open elevator during the construction. If you go to some skyscraper construction site, you can see there is an open elevator through which they carry the stuff. So you're throwing this ball with velocity v naught. Okay, and to make it simple, I'll take at the instant of projection, the elevator velocity is 0. So at the same time, elevator starts accelerating upward with velocity as with acceleration a naught, or simply let's call a. So let me write down the entire literature. Okay. So the moment you throw, it will go up. While descending, it will hit the floor somewhere here because the elevator itself is ascending up or accelerating up. So you will not hit at the same level, rather you will hit at the level above it. So we are supposed to find the time after which the ball will hit the elevator. So would you like to try this first, or shall I solve right away? Okay, no one is willing to solve now. Okay, I'll solve. Hello guys, am I audible to you?
Yes, sir.
Yes, sir.
So no one is willing to solve this question. Anyone wants to try this question? Anyone? Hello. Anyone want to try this question? Siddhant, Harry, Rugved. You want to solve this question, or shall I solve right away?
So you can solve.
Okay. So the simple way to solve is equate the coordinate, because when you hit the bottom, so your y coordinate from the given reference, I can take this as y-axis and the base as the starting point as origin. So at the time of hitting, can we say height of the the ball is same as height of the elevator? Can we write yes or no?
Yes, sir.
But both will follow different rule, because elevator is accelerating, so it is not motion under gravity, whereas the ball will move motion under gravity. Is this clear?
Yes,
So let's say the t is the time after which it is happening. So write the displacement after time t and equate it. So I can write here, for a ball, I can write v naught t minus half gt square. Is this clear? The displacement from the bottom. If the initial velocity is v naught, so in time t, how much will travel upward? V naught t minus half gt square.
Yes,
Tell me
sir.
guys, is this clear or not?
yes, sir.
But in the same time, elevator can only go up to half at square because u is 0. Yes or no?
Yes, sir.
So v naught t is actually half g plus a into t square. So t is how much? 2 v naught by g plus a. Is this clear?
Yes, sir.
I think this is easy. Yes or no? Siddhant, Rugved, Prasansa, tell me.
Yes, sir.
So if you have really understood, then solve the question 31 quickly. So I have taken the case of going upward. You can take the case of going up, coming down, and whatever. The only thing is you have to write in a sensible manner to get the answer. Write in terms of coordinate. That's why I say every challenging question can be solved with ease if we stick to the coordinate way of writing things. Okay. So solve 31 and you are done for the day. You can leave or you can
So
stay.
why did we take u as 0?
It's written in the question. Because v naught, if I take u as u, okay, let me tell you something very interesting also, because I don't want to discuss here because we are going to discuss this again in relative motion, but assume the motion of the elevator is u. In that case, I will throw v naught with respect to elevator. So this will become in ground form v naught plus u. So v naught is the velocity with respect to elevator. Let me mention with respect to So with respect to elevator, the velocity is v naught. So from ground frame, it is v naught plus u. And then you can take u as the velocity of the elevator in the very beginning. The equation will look like this. Let me show you. Ut minus half gt square equals to ut plus half at square. And this ut will anyway cancel out. So what really matters is the velocity with respect to elevator.
So I don't understand why you took the velocity as v naught plus u.
Okay, so let's say you are into elevator, okay, and you throw an apple. There is an apple in your hand. You toss it. So when you toss it, you toss with respect to what? In which frame? Ground frame or elevator frame?
Elevator.
And let's say the elevator is into motion already. So when you toss it, that is extra velocity beyond the motion of an elevator.
Yeah.
So in the ground frame, what is the velocity? So for a person who is not in the elevator, who is outside the elevator, that guy will see that apple is thrown with a speed v naught plus u, because even though you're not throwing, your apple is going upward with velocity u, same as elevator. Let's say you're not throwing the apple, you're just keeping your apple in your hand, and elevator is going upward with velocity u. What is the velocity of apple right now from ground?
U.
And now you toss it, so that is the extra, no? So you toss
Yes.
it with velocity v naught in that frame. So for the ground person, actually the apple will now move with v naught plus u.
Yes, sir, I understand.
So I mean, either you can assume right now, you can ignore. See, my idea was basically to let you solve using basic. You can solve using the relative motion in one line. It's the same thing. We use something called G effective and we get the answer mentally. Okay, 31 question done. So I think in the 31 question, you're dropping the coin, right?
Yes, sir.
So as the coin will start falling down, elevator will go upward, correct? So this is the base, this is the coin. So as you drop, it will start falling down with acceleration g, so it will move half gt square. In the same time, elevator will go up here, half at square,
The elevator is coming.
and the sum must be equals to h, the height between the initial height of the elevator and the ground, isn't it?
Sir, the elevator is also going down.
Actually, it's going down. So okay, I have to make it a subtraction then. Okay, that's right. So if you start dropping, it will fall faster. So when it will hit, the elevator will be somewhere here, right? Isn't it? The coin will hit
Yes,
somewhere
sir.
here. So it will travel half gt square total, but the elevator will travel only half at square, and this is h. So can we write h plus half at square equals to half gt square? So h will be half g minus a t square. So t will be 2h upon g minus a under root. Okay. So what is given to us? What is given to
Height is
us?
given.
Height is given.
Height and time are given.
It's given in feet, no? 6 feet. Oh, how to solve the question in 6 feet? So for that, you need to remember that the value of g is 32 feet per second square. So you can't take 10. Okay. So t is given. So h equals to what is given? Okay, h is given 6 feet. 6. So I'm going to use this directly. 6 equals to half 32 minus a into 1 square, because it takes 1 second, right? Oh, what are they asking? Ah, yeah, this is one. So you can check the answer, 31. And it must be 20 feet per second square. Is that the answer? Can you check?
Yes, sir.
Okay, so let me tell you something very simple. In t time, gravity pulls anything by half gt square, no matter what. Okay. And if you also have the u, then ut is extra actually. And now depending on the direction, it could be same direction, it could be opposite direction. It's up to you. Okay. I hope this is clear.
Yes, sir.
Yes, sir.
Everyone. So this is for the day. And next lecture, we are going to start the projectile motion. So motion under gravity is done. I'm going to share some more questions for practice. Practice with your common sense, also practice with formula, practice with proper coordinate system. Just this kind of practice will make you really comfortable with numerical solving. So the more you solve kinematics, the better you will be with rest of the physics. So solving kinematics is like puzzling problem. Just solve the puzzle and get the answer. So bye guys, take care. See you in the next lecture on Wednesday. Good night.
So I
Bye,
have
sir.
doubt.
Thank you.
Bye, sir. Thank you.
Question.
Yeah, you can stay. Those who having doubt, you can stay.